Welcome to Study Loop.
First, we have to write down the reaction equations for this solution, where the solid zinc hydroxide will be dissociated as zinc ion Zn2 plus OH minus ion or hydroxide ion. And then this zinc ion will react with the hydroxide from the barium hydroxide. So zinc 2 plus will react with OH minus to form ZnOH4 2 minus. So since we have 4 hydroxide here, we have to add 4 here. So now if we just sum up these two reactions, we can cut zinc zinc. We have 2H here. So you can cut these two and put 2 here. So in total we have zinc hydroxide plus 2 hydroxide ion will give us ZnOH4 2 minus. Now the Ksp value for zinc hydroxide dissociation is 3 into 10 to the power minus 15, and Kf value for the formation of this ZnOH4 2 minus is 2 times 10 to the power 15. That means the equilibrium constant value for the overall reaction K is basically the multiplication of Ksp and Kf, and if we just multiply these two values, we'll get a value of 6. So 6 is the equilibrium constant value for the total reaction or the net ionic equation. Now we have to find the I stable for this net ionic equation. For that, we write the equation here again. ZnOH2 solid is reacting with 2OH minus to form ZnOH4 2 minus. Now if we form the I stable, since it's solid, we'll ignore the zinc hydroxide. We have to form the I stable for OH minus and this ZnOH4 2 minus. So the initial hydroxide ion concentration is 0.2, and initial concentration of this is 0 because we don't have any of them produced at the beginning. So this is initial, and then the change, if we consider the change as 2x in hydroxide ion, then change in this will be x. So in the equilibrium, we will have 0.2 minus 2x, and here we will have only x. Now if we just put these values in the equilibrium constant expression for this, where we have ZnOH4 2 minus over OH minus, and since we have 2 OH here, we have a square on top of this. So we know the K value is 6 and the value of Zn for 2 minus is X, the final concentration here, and then the concentration of OH minus is 0.2 minus 2x, put a square here. Now if we solve this equation, we will get equation like this: 24x square minus 5.8x plus 0.24 equal to 0. And if we solve this quadratic equation, we will have a value of x as 0.053, and that means the hydroxide ion concentration will be equal to 0.20 minus 2 times 0.053, and the value will be 0.09. So this is the hydroxide ion concentration. Now to find the pH, we have to know the H plus ion concentration or H3O plus ion concentration, and as we know that we can easily find that by relation with Kw over OH minus. So if we just put the value of Kw 1 times 10 to the power minus 14, and bottom we have OH minus concentration as 0.09. So ultimately we'll have 1.06 molar H3O plus. That means the pH is the negative log of H3O plus the negative log of 1.06, and finally we have okay, this is 1.06 times 10 to the minus 13. So that means here we have 1.06 times 10 to the minus 13, and ultimately we have the pH as 12.97. So this is the pH of the solution prepared from 1 liter 0.1 molar barium hydroxide and excess zinc hydroxide.